What is going on? We are back. First take right here with the Kodiak Killer. All right, this is the first take. We're coming off the rip here. All right, we're back here with the LinkedIn Learning. Ladies and gentlemen, we did a lot. Yeah, I actually just got through debugging this bad boy. Use a little bit of. We're gonna jump. This is gonna be a short video. I'll try to keep it max 20 minutes, but it's gonna be jam packed with content. Right now, this is an absolute mess. We got the try catch block right here. We got basically the same try catch block right here. Stick with me. And we're going to refactor that towards the end of the video, and I'll explain everything. But we have some Unicode characters. Um, I'll just shut up and show you the app really quickly. Uh, Obviously, it's just a console application, but uh, still kind of cool. Ran into a lot of stuff. So basically, the idea in this LinkedIn Learning Challenge was to um, make a deck of cards. So if you've ever played cards, you know you have 52 total cards. You have four suits, and then you have 13 different um, cards. So you'll have two, three, four, all the way up to 10. Then Jack, Queen, King, and Ace. So the goal of this was, and this obviously you can see the suits, which I'll talk about here in a second. But um, basically, we get a blind all in. Let's play. Enter one to play. If you can't stand the heat, then enter two and get the out the kitchen. Um, so if you stay to the end, or you can fast forward. Um, but I don't know why you would fast forward to the end because we're about to get into it. Um, we're gonna play a little game. The first, I'm gonna press one. We're gonna play. The first set of cards is gonna be my cards. The second set of cards is gonna be your cards. So, pretty good at poker, and I am a lucky man. So let's get into it. So, like I said, the LinkedIn Learning Challenge posed the challenge. Okay, we need a function that randomly shuffles a deck of cards and objects. Now keep up because I'm going to go kind of fast here. It's going to be jam packed with information, but we're rolling, and this is honestly one of the coolest, um, albeit a console app that I've used, that I've coded. Um, so we need a function that randomly shuffles a deck of card objects. So in .NET, there's a random class that provides different functionality, which we'll look at, that basically randomizes a set. We're going to input a function that takes in a list of strings. We created that list of strings right here. Each string representing a card. Okay. Um, and I will say this is a generic list of strings. Learned a little bit about generics and their role that they play with collections today, but that's out of the scope of this video. So we are not going to get into that. So it takes in a list of strings and then an output returns a randomly shuffled list of those same cards. But I took it a step further. So I returned a randomly shuffled list of those same cards. And then I just did a little for loop, and I'll show you. I'll work through my code here in a second. Um, just to get two cards, or I guess get the first two cards out of that random set, which would be the top of the deck, which should be your cards. And also throughout this video, I am going to, because obviously this looks like this is bad, this is terrible. Um, from a syntactical perspective, from a clean code perspective, um, I've watched some stuff on clean code here in the past, uh, a couple days, and man, there's a lot of stuff that I did not know about clean code, best practices and stuff, but it really does clean everything up. So we're gonna make an attempt here, um, and that's actually why I created this duplicate try-catch block at the bottom to kind of separate concerns a little bit, and then I'm gonna kind of parlay off of that and go into an explanation as to why that would be beneficial. Normally, we wouldn't put everything into the same uh, project.cs file. Normally, the class would be in a separate file, but we'll get into that. All right. So, abiding with clean standards, we are going to get rid of what is called zombie code. You already know the instructions. I just gave them to you. Gone. Cleans everything up. All right, so first we're starting with a new list of strings, a generic list of strings. And now we're going to create two string arrays, one called ranks and then suits. And then, see, if this was a string of, if this was an array of characters, we wouldn't be able to add the 10 because obviously you have a 1 and a 0, so you got to represent. So you have two characters, anything more than two characters needs to be put into a string, so that's why we chose string here. And then we get into Unicode characters represented in .NET. So a string, an array of strings, and then these are our Unicode characters, which represent our, what do they represent? Our diamonds, our clubs, our hearts. What the heck are these things called? I just said them. Our suits. Oh, right there. Pay attention. All right, so now we create a blank string, an empty string called new list item, which we'll see here in a second. All right, so we go ranks.length. Um, and so ranks.length, so we have 13 here, but really it is, yeah, it's 13. So uh, we are going to do this 13 times, starting at 0, ending at 12. Um, man, hold on. Yeah, okay. And then our new list item, so we have our ranks. So we're going to have 2, which is going to go there. And then we're going to run a nested for loop, which is going to, for 2, obviously, when you have 2, you have, for 2, you have 4 different suits for that, for that 2 card, for that number 2 card. So that's what we're doing here. And then we're just iterating through and creating a new list item. Okay. And this is how, while we're on it, this is how we're able to use the Unicode characters and get the suits, so the hearts, the diamonds, the diamonds, the clubs, and whatever the other one is. All right, so I say, no, this is cool, but we really have to take into account big O notation here. All right, so I was kind of scared that since I had a nested for loop, that doing this would go into quadratic time complexity, but it actually doesn't because we're still staying linear. So basically, what that means, I'm not completely well versed on big O notation, but um, the amount of times this runs is like equivalent to the number of characters we have is equivalent to um, so the product. So we would want this to run 52 times in a deck. So it would be the product of this times this, linear time complexity. I may be wrong on that, but the bottom line is that this does not, so I was worried about nothing. This does not get into quadratic time or space complexity. All right, question. How do we remove a layer of complexity from our time or space complexity? And the answer is, well, we really don't need to in this situation. All right, getting rid of the zombie code. Question, how can we actually see the difference between space and time complexity within our IDE? Now, that is actually a really good question that I wasn't prepared to answer. How can we actually see the difference between space and time complexity within our IDE? Well, one way you can see the performance on the CPU is one way. let's go ahead. This is a quick question for ChatGPT. Let's go. Let's ask real quick. I am way too big. Alright. In your IDE, like Visual Studio, you can't directly measure space and time complexity, which are theoretical concepts. However, you can profile the runtime performance and memory usage by looking at your CPU, your code to observe, memory usage of your code to observe its behavior. Right, okay. So the bottom line, so we can use a profiler, Visual Studio profiler can give detailed insights into both CPU and memory space. So the profiler, we can use that. Okay, profiler, get into diagnostic tools, use a couple of the base class libraries, such as I think it was like I actually learned about it today, like system diagnostics something, which basically I guess might allow us to do that. But long answer short, that kind of answers our question there. So we'll hop back over, delete this zombie code now that we have that answer partially answered, question partially answered. We've gone over the Unicode. For each string s in list console.writeLine s, so we created so we're continuously adding to our list. So up here, right, we created a generic list of strings, and our new list item is a combination, like we just talked about, of the number, or in the case of Jack, King, Queen, or Ace, we can take those into account as well, paired up with the suit. So that is where the blank is coming in, and we're continuously adding that to new item, and then right here we are adding a new list item to our list. So I will actually, just so you guys see what I'm talking about, I am going to quickly make sure my breakpoint is off down here. All right. So I am actually going to set a breakpoint right here really quickly, and let's go through that because debugging is extremely important. Wait for that to load. All right. So let's go. Let's go. Let's go. All right. All right. We got about 8 minutes here. We're gonna get there. All right, so we have our new list item. We come down to the locals window. New list item right now equals 2. I guess it starts at 2. But as we're stepping through, okay, if I would have put the breakpoint right here, then new list item would have been blank, but we're starting right here, and the first one in ranks is 0, so the first element at index 0 is going to be 2, so we're starting at 2, so that's fine. We'll start at 2. So here, I forget what these Unicodes actually represent, but we should see as we're stepping through, we should see a suit come up right here in our new list item. So that's how we would know that our for loop is working. So let's step through. So we have new list item plus, once we hit this, suits of J. So right now J equals 0, and we have our suits array of strings. So whatever this Unicode suit, whatever this Unicode represents as far as the suit, that's what's going to be. So let's go ahead and step into. All right, now, right when I click this, you're going to see the new list item update. Okay, so we have 2 of hearts. Okay, fine. We go through, and now back to 2, going back, so now we'll see a new one right now. Look, we're looking at the new list item down there in the locals window, the one that's highlighted, so we'll see a new one. So 2 of hearts, and it goes through the entire process like that. And as you saw initially, that's where the entire list or deck of cards comes from. All right, we'll take that breakpoint off. We're going to stop the program and get back to the explanation. All right, so there we have our list. So the list is a deck of cards, so we're just printing out the deck of cards. And I say to do. Now we want to actually randomize our list into a new list because obviously we want our deck to be shuffled. We're playing Texas Hold'em. And then I say, okay, I'm thinking that we create a shuffled list of strings. Okay, that's fine. We did that. Create a shuffled deck, which is a generic list of strings. Okay, so now we created a class down here, which really, like I just said, this should be in a separate file, but we created a class called deck shuffler and then a method within the class called shuffle that deck, which takes in a list of strings, um, which takes in a parameter of type list of type. Is that what it's called? A type? You say it like that? Type generic list of strings of called list, whatever. Um, so we created a static method called shuffle that deck in our class, so that's why we are able to call that right here, deck shuffler, shuffle that deck list. Now we have our shuffled deck. Okay, and basically, like I said at the beginning of the video, we're using the random base .NET class, and then we actually get into link, and then we use a lambda expression. And one thing about the lambda, or one thing about, yeah, I guess link and lambda paired together. So when we're writing or constructing language integrated query and using a lambda, um, we set a parameter and then basically, so it's not really doing it here, but basically one of the things I struggled with when I was initially working with language integrated query and lambdas is like why is this p here and where's the parameter coming? If this is a method, then how does it know what type it's dealing with? But when you're working with link, it automatically, for some reason, infers the type that we're working with. So list, it knows that we're working with strings. So in the end, we're able to return shuffled, which is a list of strings. So deck shuffler, then we call shuffle that deck, which is what it's doing. Get rid of the zombie code, abide with the clean principles. All right, we shuffle that deck, takes in a generic list of strings called list, and that we have. And now we get into our UI, console.writeLine. This is just what we're saying with, in the UI. And then we want to read the user input, so the user can either input a 1 or 2, and we got like 2 minutes to spare. So I really have to get going here. Um, if you're still with me, um, let's keep going. All right. Uh, Hold'em cards. So now it's randomized. So the shuffle deck is randomized, and we are creating Hold'em cards, which is going to be um, the 2 cards that we're getting back, and we're setting Hold'em cards as an array of strings, and it's just going to be a length 2. All right, so now we try our inputs. So if user input equals 1, then we are going to um, iterate through, we're just going to get the first 2. So Hold'em cards dot length, right, is 2. So we're just going to get the first 2 elements in the shuffle deck. So at this point, it's randomized, and we're passing that into Hold'em cards. So we'll eventually get our 2 cards. I want to print out a message based on the output of my cards. I think we should print cards to a string so we can compare. And then right here, I got into a little bit of regular expressions. And .NET, if you want to use regular expressions, you can just use the namespace. Using system.text.regular expressions. At first, for this, I tried to use I try to use matches here for the method for the well, matches didn't work. The method you should use to try to find a match based on a regex is match. I put a to do. We need to implement the king or ace pattern. And one really cool thing with um, Visual Studio, when you have your to dos, you can there's task list. So you can go to task list and it should show you your to dos. So which is kind of cool. Uh, you can add if you're in Visual Studio Code, you can add an extension. I think I have it up. Uh, you can add this to-do tree extension, um, which kind of allows for the same functionality, but it's already there natively in Visual Studio. So we don't need that anymore. So I tried to do regex, we need to include the regex class in our namespace. Stick with me, we're almost there. Past 20 minutes. Like I said, this is jam-packed with info, so um, it's a lot. But we will keep chugging along as fast as we can. All right, so we created our regular expression. So basically what this is doing, so we new up a regex object, and basically this says the -1 right here. This is pretty much all I need to know about this. The -1 or the backward slash 1 is saying if there's a duplicate of any of these, so 2 through 9, then um, AKQJ, then we will print. You've got a pair, not terrible. I definitely got a pair. Then we will, so for accounting for the 10, so this is a little bit tricky. All we would really do here is go, since you have a 1 and a 0, you will go 10, and then that, I believe. Um, just that line. What is that called? Over here, what is that called? What is, I'm slowing down here, people. What is this line called? I don't know. What's that thing called? A pipe, vertical bar, okay? Our pipe. All right, so we just need a 10 and then a pipe, basically. So we can get rid of this. And then I was gonna add a little message. If we got the cards that had an ace or a king in there, then I would print out your chances are high or something like that. And this is actually not the correct way to do it. You would actually just do I'm pretty sure. I'm pretty sure I'm wrong. But whatever I had before is not the correct implementation. But let's actually go ask real quick. What's the correct implementation for finding a set of cards with either an ace or king? Here's what I have. So what I need to change this to real quick. Simple regex. Card out your current ace pattern is looking for the exact string KA together rather than either A or K independently. So what we would need to do, I'm not going to do the if else and console.writeLine functionality, but just so we know for future reference, to find either ace or king in the card set, you should use a pattern like AK, which matches either A or K regardless of their position or order. So right here we strictly use the square brackets. We don't need the uh, parentheses. All right. So for the um, taking time into consideration, we are just going to stick with this. Um, is my 10 implemented properly? Is my 10 and the regex implemented properly? No, it's not. As with the /1 part, which is a back reference to the first capturing group. This works for a single character like that, but doesn't work for 10 because 10 consists of 2 characters. That's why I put the pipe. Here's a breakdown. The /1 back reference expects the same match as the first group, but this doesn't work properly when 10 is involved because it's more than one character. Correct regex for pair, including 10. To handle this properly, you need to check for pairs in a way that allows for both 2 character and single card values. I have my pipe, don't I? There's my pipe. Is my pipe not working? This part matches either value 10 or any of the single ranks. This optional back reference allows matching for a pair where the first match could be repeated, for example, 10 and 10 for a pair of 10s or A for a pair of aces. All right, we'll take your word for it, ChatGPT. All right. All right, so now we do our comparison. So pair pattern, here's our regex. Is match card output. Our output is our 2 cards that we get. And then I say if user input equals 2, then we return because you can't stand the heat. You got to get out the kitchen. We get it. You got short money. It's all right. Else throw, and for the longest time, I could not get exceptions wrapped around my head, but they actually something clicked today. Which like if you're still watching this video and number one, you're dedicated. Number two, um, just stick with it. Like the more you expose yourself to something, you're eventually gonna get it. Just keep going. Um, the first time you see something new, like learning is not, it's like working out. It's not, if you're doing it right, if you're really pushing yourself, it's not fun. The fun part is being more athletic than everybody. The fun part is being smarter than everybody, knowing more stuff than everybody. So just stick with the difficult times. If you don't understand it, realize that learning new stuff is hard, and just stick with it. Um, so back on track. Um, so basically, um, if user input doesn't equal 2 or 1, then we throw a new argument exception. So and then else we throw what we have to do. This is the key. We throw the exception. We throw the exception. We throw the exception. We throw the exception. Okay, we've thrown the exception. Now, after we've thrown the exception, we have to catch. We throw it up in the air. We throw the exception up in the air. Now we have to handle or catch that exception. And if you can get that wrapped around your head, you're good. Now, granted, for this scenario, a try catch block and exception handling is probably overkill, but I needed the practice, so I did it, and it finally clicked. So we write our message to the console line, and then we handle that exception by calling card handler, which takes in hold'em cards and shuffle deck. Recall the method here to start over. Not sure what that means. We already answered this question. How can we make the above nested for loops more efficient? Well, they're already maxed out on efficiency. Um, Probably not maxed out, but they abide with linear time complexity, space complexity. So then we call in our deck shuffler class. So this would be best practice. Having all this, I'm not going to get into it because just for time purposes right now. But obviously, if you've ever done any code, and I'm actually like I said a while back in this video, if I just encountered some of the clean coding principles, and it was actually quite interesting just to see, the different ways you can make the readability of your entire program a lot better. And regardless, this program right here is absolutely horrible when it comes to clean code. Um, and these practice sessions are mainly just for uh, logic and working with base classes, but I really should. This method down here, this right here, this try catch block should be in a separate file in a new method, really is what this should be. But regardless, in this scenario, we have our card handler, which takes in a string of hold'em cards for this method. And another one is, this is another big point, and I'm sorry to keep rambling on, but okay, so throughout this process, we've been deleting our zombie code. Another big thing that I thought for the longest time was that for every little thing that I didn't know or didn't understand or something like this, what did I try to do here? Okay, this needs to go. Like, this is bad. Because there was a concept of like, um, so you want to reduce the level of noise because reading other people's code is very difficult. Like, you guys probably had a terrible time trying to like understand what was going on in my code right here. Not because you don't understand the concepts, but because I went through it and I wrote it, so I know exactly what's going on. Reading other people's code is hard, and when you put in comments like that, it the person reading it is inevitably going to read that. Their eyes are going to be there, and that's just added noise that distracts them from the real logic and the real stuff in the program. So stuff like that, like adding extra comments, we should assume as developers that another developer can understand what this is talking about if they're on our software development team in an actual company. Like we don't have to explain what it's doing. All of our thoughts and opinions have to go. You know, that's what makes clean code. We want to reduce the noise that is in our application. Um, so finishing strong here, basically what I did here was recursively call card handler. Um, if it throws, if the user inputs something other than one or two, we don't return. We throw our exception, then we catch our exception, and we recursively call the method until the user does input one or two, and then after those conditionals are executed, then we return and our program ends. So that's it. Now for the fun part. Let's see who takes all who's gonna take the money home here. It's gonna be me, but best of luck to you. So My blind draw is going to be, all right, 9 ace. So you're basically done for, people. All right. So I got matching suits, ace of clubs, nine of clubs. I mean, let's see what you get. Like, we're not gonna run a simulation on this, but it's looking pretty good for me. I'll see what you get. Jack of heart, two of diamonds. You know, I hate to say I didn't tell you, but the odds are the Kodiak Killer is gonna come out ahead. Um, wow, that was a lot of information. I was hoping I would get to the point where I had enough time to actually refactor this because this is terrible. It's just the logic is there, it works, but definitely to buy with clean coding standards, it needs to be refactored in the future. But obviously, running out of time. We're way past time. Um, Hope you guys enjoyed. If you're still with me, hope I didn't bore you to death. This is some pretty cool stuff. This is actually probably my favorite program that I've written, YTD. Uh, this is pretty cool. Like regex was in here, worked with a little bit of Unicode, worked with some generics, got in some loops, got in some try catch, got in some conditionals, some arrays. I mean, worked with the random class, inserted, worked with some um, .NET base class libraries. We had it all. So I hope you learned something. I'm out of here. You guys take it easy. Peace out.